We have another example on the board. Again, we're supposed to prove that the left side of the equation is equal to the right side. Please notice that the left side is kind of long and looks kind of difficult. That's why I'm going to start proving this equation from the left side. Let me copy down the left side, and I have tangent theta, and I have cotangent theta, and I have cosine theta plus tangent theta sine theta. Now, this is equal, of course. Now, I'm going to copy down tangent theta and cotangent theta I'm going to rewrite using the reciprocal relation, which is simply nothing else, just 1 over tangent theta, okay? Because cotangent theta is equal to 1 over tangent theta times cosine theta. Now, because I have a fraction over here, I can convert this tangent to fraction and this cosine to fraction. Tangent and tangent will cancel out. Plus, now, I have tangent theta times sine theta. What I can do over here, I'm going to convert tangent theta to sine theta over cosine theta. This is the quotient relation of tangent theta, and I have times sine theta over 1. I wrote sine theta over 1 because I have a fraction over here. I convert this sine to fraction too. So let's take a look what we have. We have cosine theta over 1 plus sine square theta over cosine theta. We have two fractions. We're supposed to add them up. In order to add two fractions, we're supposed to find a common denominator. Common denominator for these two fractions is cosine theta. Okay, so I'm going to write two fractions with the same denominator. Okay, in order to write cosine theta over here means I have to multiply 1 by cosine theta. That's why I'm going to have cosine theta. And because I multiply the denominator by cosine theta, I have to also multiply numerator by cosine theta. That's why I'm going to have cosine square theta, because cosine theta times cosine theta gives me cosine square theta. Plus, and simply copy down this fraction because we have already cosine theta in the denominator. So I have sine square theta over cosine theta. I can rewrite this problem as cosine square theta plus sine square theta over cosine theta. Please notice that in the numerator we have Pythagorean relation, which is simply equals 1. Cosine squared theta plus sine squared theta is equal 1. That's why I'm going to write 1 over cosine theta. Reciprocal of cosine is nothing else, just secant. So that's why I have secant theta. And we simply proved that the left side of my equation is equal to the right side.